Hi Lana, hello and welcome to Lana's Coach. So today we are going to have a discussion on computer architecture, right? But there are two terms that we need actually to understand before proceeding. This is computer organization and architecture. Now, these particular terms are closely related. Yeah. When you talk about computer architecture, this represents the blueprint. Yeah. The structure of the computer itself. Talking about the connections of various components, right? So, in simple terms, you can define a computer architecture as a connection or bringing together different components, right? So that they can work together to arrive or achieve a particular objective. This objective could be maybe to enhance performance, to execute some kind of instructions. Whereas when you talk about organization, as the term means, we can always organize various computer components, yeah, in a given manner. Like talk about input devices, that's a kind of an organization, right? So when we pinpoint some kind of organized components within the computer, we talk about computer organization. So we can say that these are the physical arrangement of various hardware units. I've just mentioned the input, output. Yeah. So if you can be able to represent, yeah, some kind of organized component within the computer, then we say that that is the computer organization. So you can see there's a thin difference between architecture. Yeah, architecture doesn't represent any organization. Yeah, it's the blueprint of how the computer is connected. Whereas computer organization arranges those components into a specific manner. So with that kind of understanding, let's look at maybe further how the various computer components are organized. So I've mentioned that we have the input devices. So that's represent one part of the organization within the computer. We also have output devices. We also have the memories, and we also have the CPU. So in total, this one now we can say we can now talk about the computer organization and also talk about the computer architecture with respect to how the various components of the computer, how they are connected. So you can see the arrows shows how the connection happens, right? And this is what we are going to look at. Yeah, how does the central processing unit work with the primary memory? How does the central processing unit work with various output devices? Yeah. So maybe we can always imagine that there's a board or a circuit board that this kind of connections lead to. So we are going to also to look at the motherboard, where the input devices are connected to, where the output devices are connected to. So in totality, this one will represent the computer architecture, right? So in understanding the computer architecture, also we need to understand the operations of these different computer components, right? So when we talk about input devices, how do we ensure that the computer fetch the instructions? Yeah. So we need to understand the operation from the input aspect, right? We can only achieve the inputting factor through the use of various input devices, which we are going to highlight briefly. Also, the computer operation needs to have some kind of storage capacity. Yeah. After the CPU has processed the data, where do we store these? So we're going to look at the storage in terms of a volatile memory and also non-volatile, talking about primary memory and secondary storage. Now, the vital operation of the computer is actually the processing aspect, right? So we are going to understand how does the CPU function, or how does the computer achieve the processing function through converting the raw data into useful information. Again, we are going to understand how the computer outputs whatever it has processed using the different output devices. Other key function of the operation of the computer is actually the control aspect. Yeah, how does the computer manage to monitor and regulate this kind of operations? Yeah, operations when you talk about inputting aspect, operation when you talk about storing aspect. So we need to control the amount of instructions that the computer, the CPU can be able to process, and the amount also of instruction that it can be able to to output. So ideally, the architecture of the computer are the physical aspects. Yeah, the arrangements talk about the interconnections. So when we talk about the computer system here, we need to understand the hardware, how the layout of the hardware is actually executed, the kind of software that allows this hardware to function the way it's supposed to function, the instructions, be it the data, right, unstructured data, unstructured information. We also have the people component. Yeah, as a computer cannot be able to function without the interaction of users. These are the people. People are required to issue instructions and actually to monitor how the computer performs. So I've mentioned that the computer architecture comprises of the hardware. So you can see the diagram here showing the different hardwares. So here there's no kind of arrangement. So we can't pinpoint that these are input or output devices. So the architecture here is not well defined in terms of organization. So when you organize computers, we can talk about input devices, output devices, and so on. So talking about the input aspect of the computer, we refer to different devices. But more specifically, input devices are there to give instruction, right? When you want or instruct a computer to perform a particular task, we use the input devices, right? So the idea of input devices is to send data, yeah, to the computer itself, right? Get this clearly. Input devices can only send data. Data could be instructions to the computer, yeah. The instructions could be as simple as tapping on the keyboard for a particular character or moving and clicking around within your computer, right? So examples of input devices are numerous. You can mention them. But most importantly, we need to understand how does the CPU or computer process the input or the instructions, right? So that is one part of the computer architecture, the input devices. We also have the output, yeah. Sorry. So output here perform the functions of receiving data. Once the CPU or the processor has already processed the instructions, it needs to display them or store them, right? So what will enable the computer perform this kind of task is via the output devices. So we have examples of output devices, yeah, such as speakers, screens. You can be able to mention others, right? So you see the control aspect that the computer uses is very, very important, and you're going to see the control aspect of the CPU. Yeah, it is the one to determine what to output. It's the one to determine which kind of instructions to be able that the computer can be able to process. Again, sorry, we have other devices that have the capability of sending and receiving instructions at the same time. Yeah, we talk of the I/O devices or the input-output devices. So these devices can be able to send data to other devices and also receive, right? So we don't have many devices in this particular category, but you can talk about maybe the fax mile, the touch screens, yeah, like for example the smartphones. Yeah, you can be able to display and touch on a particular maybe files for them to open and so on. So ideally, when we talk about the computer architecture, also we need to understand how the input-output devices also function. So we have also the computer cases, right, that you can be able to see. These ones are the external or the external hardware that houses the internal components of the computer. So we can't rule the computer cases out because they're the ones that houses the internal components of the computer. So we have different kind of computer cases that you need to understand, right? As you can see, this one represents the tower shape. We also have the desktop shape, yeah. This other diagram shows now the inside of the computer cases. You can see the cables, yeah, the wire cables. This one actually, I mean the power cables. This one's actually ensures that the computer can be able to power the internal components, right? So whatever we get inside the computer case is actually one of the main computer architecture, and that is the motherboard, right? So it's actually, the name comes from the fact that it actually takes care, yeah, of different components. I think that's where the mother comes from, yeah. So it actually, or different components are connected to the motherboard. So without the motherboard, actually, you can't talk about the computer architecture, yeah. It comes with different names. You can call it main board, you can call it system board, and also you can call it printed wired board, right? Some people call it the main circuit board of the computer, and so on. So the vital components here that you can be able to pinpoint is actually the CPU. CPU is normally connected to the motherboard. We also have the main memories, right? Just to mention, maybe they're here. You can see, talking about the CPU, talking about the main memory, these ones are components that you can get there. We also have the basic input-output system, yeah, the BIOS. We also have complementary metal oxide semiconductor. This one is the CMOS battery that stores, like for example, reminds the computer what it did, or the time and the date, right? We also have the cache RAM. We're going to understand more about this. We have the CPU clock, expansion slots, and name them. Yeah, so the motherboard houses, or actually is connected to, or allows various components to connect to it. So one of the components that you're going to look at is the processor, right? Processors comes in different flavors. As you can see, this is a very old processor diagram here. But again, it's very important to understand how the processor function. Yeah. So it's the processor, as we normally refer to it as a brain of the computer. It needs to execute kind of different instructions. Not only execute those instructions, but manage those instructions to the point that they make sense to the end user. So the main functions, or the main components of the CPU are the registers, or the main memory. We also have the arithmetic unit, right? We also have the logic unit, control unit, and cache memory. So what are these components? Yeah. So as you can see, the registers contains few special purpose, or the temporary storage units. Yeah. They are high speed memory locations for holding instructions, right? Maybe a good example is that when the processor is processing a lot of instruction, it normally uses registers, yeah, to store some kind of instructions temporarily, right? Maybe these are very important instructions that it needs to process. Again, it also uses the main memory to store these particular instructions, right? So the main memory here, we normally refer to it as the RAM. Remember, RAM is volatile. Volatile in that when the computer loses its power, you also lose your content. So we also have the arithmetic unit, part of the central processing unit. This one is established to perform operations such as addition, subtraction, multiplications, and division. So you wonder why the computer is always accurate. So here is what, or this is the component that enables arithmetic operations to be executed. You also have the logic unit. Yeah. Now logic, it actually represents the way the CPU logically does its function. For example, if it wants to compare, yeah, it wants to compare some kind of operations of parameters, it uses the comparison factors such as greater than, yeah, maybe equal to, or so on. So those are the logic unit. For the control unit, this one also performs a very, very vital function in that it monitors and controls the flow of data information. How does it do this? It does this through monitoring the instructions from the input, yeah, determining in the order of priority maybe which instruction to be executed first and maybe which one to hold. And then also on the other side, once the processing aspect has been established, it also determines the kind of instructions to display and so on. So it maintains the sequence of operations being performed by the CPU. We talk about the cache memory. This one boosts the functions of the main memory and the registers. Here, the CPU uses the cache memory to store, yeah, frequently accessed instructions. Yeah, so it stores the copies of those particular instructions. So it saves the computer or the CPU the time of going to the main memory to fetch the instruction from there. So it just uses the cache memory. I think I'll use a particular diagram to elaborate this. Now, ideally, the central processing unit performs these particular operations in 4 phases. We have the first phase, the fetch, the second, decode, execute, and store. Now, when we talk about fetching, the CPU needs to fetch instructions that are stored in the main memory, right? So that it can be able to do what? To process. So that is the fetching. So it does the fetching of the instruction from the main memory. When we talk about decoding, it needs to understand the instruction before it executes it. Yeah, like for example, it needs to understand, is this a music file that needs to be played? Is this a word file that needs to be opened? So decoding aspect enables the CPU to understand what it should do. After it has understood what the operation requires or what it requires to perform, it needs now to execute that particular instructions. Yeah. So execution happens based on some kind of aspects based on the control unit. Yeah. It determines what is to be executed first and so on. And then after execution, it determines either to store this particular data within the hard disk or any storage device or within the main memory, or better still, it can display this kind of information. So as I mentioned, there's some kind of steep learning curve as to how the CPU does or executes its operations. We can't really talk about the CPU successfully executing its operation without understanding how the communication happens between these vital components. So we need to understand the internal communications that happens within the CPU. So we have 2 major categories of communication. This is the communication between the processor and the memory. When we talk about processor, we refer to as the processor fetching instructions from the memory. So how does it do this? We also have the processor communicating with the input and the output devices. So these are 2 major communications that we need to understand. So how does the processor communicate with the main memory, right? This is courtesy of 2 registers. Yeah, the processor needs to actually fetch instructions from the various memory addresses. Yeah, so this process is performed through memory read and through memory write operations. Yeah, so we also need to understand how this happens behind the scene. So, but for now, just understand that the processor needs to communicate with the main memory by understanding how to allocate the various instructions and to pick the instructions from the addresses. We also have communication between the processor and the input-output devices, right? This happens through the implementation of an interface unit. The processor needs to know the kind of the kind of instruction that is processing. Is it from the keyboard? Is it from the mouse? And what does it? What kind of resources are these particular I/O devices that they are using? Yeah. So this particular interface unit acts as an intermediary between the processor and the device controllers of various peripherals within the computer. Yeah. So this is a very important aspect of the communication that you need to understand. When you break down The communication channel, also we need to understand different cycles that the processing aspect undergoes. Yeah. Now we have three cycles: the machine cycle, instruction cycle, and also the last is the execution cycle. When we talk about machine cycle, machine or the computer doesn't understand the characters that you type on the screen. So it needs to convert them to a language that it can be able to do it, to understand, so that it executes that particular instruction. So the machine needs to convert the kind of character or the instruction that you have fed into it by using the machine language. Yeah. So after understanding the instruction is when now it can proceed to execute that particular instruction. So in the instruction cycle, I think I've already mentioned that the first process is to fetch the instructions from the main memory, right? After fetching them, it needs to break them down so that it can understand them, right? And this process is what we have referred to as decoding. The last and the final part of this particular cycle is the execution cycle. Yeah, so it needs to execute this particular instructions, and it does this through the arithmetic logic unit. After that, it can be able to store these particular instructions or even output them using the various output devices. Right. So you might ask, how does the computer, I mean the memory, the CPU, transfer the instructions from the main memory, maybe to the logic unit or to the control unit? Yeah, it does this through a set of wires known as the bus, right? So a bus is a set of wires that is used to connect the different internal components of the computer system for the purpose of transferring data from the main memory to the processor. Now, the analog of this is we can take an example of a road or the lanes that are used by motor vehicles. Yeah. So the larger the lane, the more the vehicles that can go through. Or better still, if you have more lanes, many vehicles can use that particular road. Talk about the super highway, right? So we normally say that if you have a bigger or a wider data path, the more the instructions a computer can be able to do it, to send and receive, or the processor can be able to fetch and execute. So our latest technology that the computer uses can handle up to 128-bit data buses. Yeah, currently we are using the 64-bit. We normally use the 32-bit. Yeah, which was a bit faster, but you can't compare it with the 128-bit, which is very, very, very fast. So the larger the data bus, the more instructions that can be transmitted at a given time. So you can't talk about the speed of the processor without understanding the kind of path that the data is actually being transmitted through. So we also need to understand the address bus. Yeah, so these are the memory addresses that the CPU uses to actually understand the locations of the instructions. So this particular diagram summarizes the key functions of how the CPU actually executes its operations. As you can see, we have in the middle the main CPU, and then on the left side we have the main memory and actually the auxiliary storage or the external storages. We also have on the right side the input-output devices. The connection happens, we can see there are some kind of lines. The red lines represents the data, and the dotted lines represent the control mechanism. So borrowing from what you have learned, you can see that the cache memory presents a platform that allows the CPU to quickly get frequently accessed information or actually instructions instead of going to the main memory, right? Arithmetic logic unit sits at the center there. Yeah, we have seen that the main function is to subtract, add, and even compare. We also have the control unit. Now, the control unit uses the dotted lines to control the instructions from the input-output devices, right? And maybe store them within the main memory and so on. Then after that, the input devices can also transmit data from the main memory, right? And also receive that particular data, right? So you can say that is what we have discussed. The diagram there represents what we have discussed, the fetch, execute cycle. Now, talking about memory and storage, right? As memory or the computer architecture has different categories of memories. We have the primary memory, that is also known as the RAM. We have looked at the random access memory. You also have the secondary memory, yeah, also known as the external memories, such as external storage devices. We also have internal process memories. We have looked at the registers. We have also talked about the cache memories. These ones are placed near the CPU, right? Now, how do we represent information within the memory of the computer? So the smallest unit is normally known as the bit. The computer only understands two languages, 1 and 0. So it needs to convert any kind of data or character into bits, ones and zeros. So the combination of 8 bits is known as what? A byte. And a byte in normal scenarios represent a what? A character. So a byte is normally the smallest addressable unit that the computer stores the information. Yeah. So the CPU can identify each cell by its memory address. So when we talk about the smallest addressable unit, which represents the byte, yeah, and from the byte we can now have other representations such as kilobyte, and 1 kilobyte is normally represents 1024 bytes. 1 megabyte represents 1 million, and so on, yeah, bytes. So the representation of data in memory form is very, very important. So when we talk about the main memory, we have the random access memory, referred to as RAM. We say that RAM is volatile, yeah, in that it loses its data when you switch off your computer. We have different categories of RAM: static RAM and also the dynamic RAM. So static RAM is that type of RAM in which data is stored until the power or the computer is switched on. Yeah. So static RAM uses a number of transistors to store a single bit of digital instruction or information. We also have dynamic RAM. This kind of RAM, data is stored in a storage cell consisting of both the transistor and the capacitor. So the DRAM actually needs to be continuously refreshed with power supply because the capacitor has the tendency of getting discharged. So these two kind of RAMs are very, very important. Yeah, the dynamic can always store some kind of data even after the computer. Store some kind of data even after the computer has been switched off. The other category of memory is what we refer to as the random read-only memory. Read-only memory. Read-only is non-volatile in that even if you switch off your computer, you still retain your data. So normally they say that it stores data permanently, right? When we mention the BIOS or the basic input-output system, this is an example of a read-only memory, which stores manufacturers' information. So there are different devices that use ROM. We can also talk about ROM in terms of hard disks, flash disks, and so on. The most important thing to understand about ROM is that it allows random access of data, right? And also allows sequential access of data. Again, ROM is divided into 4 types. Programmable ROM, right? This actually stores data permanently without making any change in it. Yeah, it's mostly used in video games and electronic dictionaries. So if you want to store data that are not easily, or you don't want to change them frequently, we can always use a programmable ROM. Now, a erasable ROM is a type of ROM in which data can be erased or destroyed using ultraviolet light. So if you want to maybe remove the content of a PROM, we use ultraviolet light. We also have electrically erasable PROM. This one uses, or you can destroy the content of erasable PROM using electric charge, yeah, so that you destroy that particular data. Again, we have the flash ROM. Yeah, it's a type of electrically erasable PROM. So this memory is mainly used in the memory cards of mobile phones, digital cameras, talk about iPods for storing data. Yeah, actually it's a very, very fast memory. Yeah, in terms of reading and when reading and actually writing data to the various devices. So you can't really compare it with other types of ROM. It's very, very fast. So the other category of memory, we refer to them as storage, right? Storage can be external. They can provide permanent storage options, and they come on three options. We have magnetic option, optical, and solid state. So magnetic storage devices are storage systems that store the data on a magnetized medium. Yeah. So we have two categories here: magnetic tapes and magnetic disks. Talking about the hard disks and so on. They can handle data in different categories such as text, audio, video, and so on. So as you can see, these are the examples. Yeah. So magnetic tapes are those like the ones that we use to store movies. Yeah. So they're plastic tapes which are with magnetic coating that are used for storing the data. Magnetic disks I've already mentioned, right? Their examples are the hard disks. And then we have the optical storage systems. Yeah. So this represents the storage systems that use laser lights as the optical medium to retrieve as well as record data. We talk about the compact discs, the CDs, talk about the digital versatile discs, the DVDs, Blu-ray discs, right? They can either be written on, or they can, you can only read on those particular optical discs. Again, we have the solid state storage devices. When you talk about solid state, what should come to your mind are the likes of the USB devices, right? So they contain all the properties that the hard disk have, yeah, to store data in a solid state memory, right? So again, they borrow more from hard disk, right, or the magnetic disks. So if you understand how magnetic disks function, you can as well understand how solid state function. Now, if you want to evaluate, for example, if you want to purchase, or if you want to recommend, or if you want to maybe get to understand the kind of storage device to use, we need to look at this particular criteria. First of all, it's important to understand the access mode that a particular storage device uses. Does it use the random access mode? Does it use the sequential access mode? Does it use the direct access mode? So when you talk about this mode, you have already mentioned random access. You can always use magnetic disks. Sequential, you can use the magnetic tapes. Direct, you can use the magnetic disks. Access time. How long does it take? Yeah, for a processor to complete a particular request made by user. For example, if you want to open a particular file, yeah, how long does it take for you to do that on a CD, on a magnetic tape, or on a hard disk? Storage capacity, which is very, very essential. Yeah, when you want to store your data, you need to look at the storage capacity of a particular device. Yeah, if you want to store a small size of data, you need to look at the small looked at this device that can enable you to store that kind of data. So we talk about capacity in terabytes, in gigabytes, and so on. Again, another criteria for the storage devices is the storage type. Do you want to have a temporary storage option or a permanent? Temporary, that one you'll be looking for RAM. Permanent, you'll be looking for a ROM option. For the cost also is very, very important. I think cost is determined by maybe the storage and the access mode and everything. Yeah. So the larger or the bigger the storage capacity, you expect it to cost more, and so on. So those are some of the storage evaluation criteria that you can always use. So let's take an look at examples of these storage media. So I've mentioned the optical discs, the tape drives, yeah. You can use the memory cards and also the flash disks, right? So if you want to understand more about the computer architecture, you can also understand how the various expansions or how to upgrade your video cards, right? So video cards allows you to maybe have a clear pixels, yeah. So these ones are normally attached to the main board, the one that you refer to as the motherboard. So we have various cards that you can always use to improve the computer architecture. The sound card enables you to have sound from your computer. The modem allows you to convert the analog waves or analog or the continuous waves into digital options. Yeah. So I think we can go on, and that one will maybe bring to a close in us understanding what a computer architecture is. So in summary or in conclusion, what you have looked at is basically the computer components that represent the overall computer architecture. So we have looked at the main component, which is the motherboard that houses the different computer components. We have also looked at how the processor functions, yeah, in details, yeah, fetch execute cycle. We have also looked at the memory, which is very, very important when it comes to computer architecture. And of course, we have looked at the tail end, the storage options. So my good learner, I hope you have gotten something about the computer architecture and how the computer actually functions, right? So feel free to engage on other videos that I've shared in my channel, and always subscribe. All right, thanks.